Bornheimer here, and today we're going to talk about the buoyancy of air. So to do this, first of all, I'm going to demonstrate this idea using a tea bag. You can get 100 of these little guys at Gordon Food Service for like $3.50. So the first thing we're going to do is we are going to go ahead and open up the tea bag. Okay. Get it all unwrapped, like so. Now, the tea bag, if you wanted to brew it, has this nice little string attached, but we don't need that. So what we're going to do is we're going to shake the tea bag a little bit to get all of the tea, which is it's kind of like a fine powder in these bags, down near the bottom. And you're going to need a pair of scissors. And what we're going to do is we're going to go ahead and we're going to cut off the top of the tea bag, like so, leaving the string, the tag, and the top with a staple in it off to the side. And we won't need those pieces. Now we still have that tea, so what you want to do is you want to grab a container, kind of like this one, and you're going to go ahead and kind of just unfold the tea bag. Now it's got open on both ends, so you want to be careful. You want to dump all that tea into a container. Now you may decide to use it later or not, but it's up to you. For our purposes, we will not need to use it. Maybe have a nice beverage later on afterwards. Okay, so we have our tube here made from a tea bag. Okay, and we're going to use this. All right, so the next step of this demonstration is going to require that we wear our safety goggles, okay, because we will be using a lighter. One of the most important concepts in weather is the idea that warm, moist air rises. This warm, moist air rising, when it goes into the middle to upper troposphere, enters into lower pressure regions where it expands, condenses, and forms clouds. And this can happen on a small scale where we have small amounts of clouds form. It can also happen on a large scale where we have large cumulonimbus clouds form, and sometimes even over the ocean where we have tropical depressions and storms and hurricanes form. This same process of warm, buoyant air rising plays a very important role in weather. So to understand this idea, we are going to go ahead, or at least see it, we're going to go ahead and use this tea bag cylinder. So I'm going to go ahead and set it here. Now, a couple things about this. It doesn't always work the first couple of times. So, on the safe side, I have a couple of extra tea bags here so that I can demonstrate this several different times. One of the great things that this demonstrates is that things don't always work the first time, but we can try them again and again and again. All right, so we have this tea bag cylinder set up here on top of this canister. Notice it's a metal surface. Okay, we have our safety goggles on. The amount of fire and ash that is produced is incredibly minimal. So, one of the things that I would caution is, obviously, make sure you have water nearby, and make sure that you're not doing this near any like flammable gases, make sure that you're not doing this near any fine dusts or substances, or even like coffee creamer. Coffee creamer is incredibly flammable, at least the powdered kind, so make sure we're not using it there. So here's what we're going to do. We're going to go ahead and we're going to light both sides quickly in succession on the top of the tea bag, and we're going to see what happens. So here we go. Notice that it's burning down, and we'll notice that, there it goes. The ash, as it falls back down into my hand, see, notice there's not a whole lot left. Oh, there's a piece there too. Notice there's not a whole lot left, almost probably non-distinguishable on this video, but hopefully you got to see it rise up off the canister. Okay, let's see if we can see this again. So we're going to go ahead and take this cylinder here, got another one. We'll go ahead and set it on top there. See if we can't get this one more time. Okay, notice it's burning down. And it lifts off again. That one was really good, okay? And the ash is floating back down very slowly. So, what is going on here is this. We've got this normal atmospheric temperature of air in this room, okay? Very small variances in temperature. And what happens is is as the fire moves down the cylinder, it heats the air inside the teabag cylinder. It creates what we talk about in weather as a parcel. It creates a warm pocket of air, a parcel, and that parcel will rise because as it warms up, the molecules get excited. They gain kinetic energy. That's what we mean when we say their temperature increases. Their average kinetic energy increases, the energy of their motion. So they get more excited, and because they're more excited, they move further apart. And because they move further apart, there's less mass in a given area. And this creates what we call a lower density region. So the parcel of air that's trapped in the bottom portion of this tea bag as it burns down, it gets warm, the air expands, it becomes less dense, and the parcel of air rises, taking with it the very, very light little bit of ash left inside or around the parcel of air. So here we go. We'll do this one more time. We see it go moving down, it's heating the air. Okay, now that little parcel is stuck at the bottom, it's heated up, and okay, and again, it didn't work that time. Sometimes that happens. All right, what happens was it got caught just a little bit right here on the canister. However, the parcel of air still rose. Okay, there was just a tiny little fragment of ash that lifted up off the canister. So we know that this parcel of air rises, and this warm air rises in the cooler air around it. Okay, this suggests two things, that warm air rises and cool air will stay lower to the ground or fall. And this idea of buoyant air plays an important role, like I said, in a lot of the weather phenomena that we'll be talking about. Thank you for watching. I hope that you enjoyed this demonstration. We'll end with one more of these teabag cylinders. Let's see if we can get it to work one last time. Guess not. Thanks for watching, and have a good day. All right, here we are again, talking about buoyancy once again. And one of the best examples of buoyancy that we can find in our homes today is in the old-fashioned, very cool lava lamp. Okay, now this lava lamp was just turned on, but there, if you look up here to the upper right-hand side, you will notice that the lava lamp there is undergoing convective currents. We see the bottom lava floating up, okay, to the top where it kind of sits for a little bit. The reason is that it's being heated on the bottom here by a light, an incandescent light bulb. Okay, as it heats up, it rises in the liquid, gets caught at the top, cools down, and begins to fall. So again, we see this pattern, this convective current, warm fluid rising, and then as it cools, it falls. Same idea. The particles in the bottom are expanding, they're gaining heat energy. That means that the particles are speeding up, their kinetic energy is increasing, the average kinetic energy or temperature is increasing. They spread out, and as a result, they become less buoyant. Now, in a lava lamp, the buoyancy between the normal liquid and the gel in the bottom is very close. Okay, just a little bit of heat creates just enough of a buoyant difference that it allows the lava, as you can see, to rise. Okay, so this is yet another great example of showing how warm fluids rise, and then as they cool, they fall. Thank you for watching, and I hope you have a great day.